Let's talk about rational exponents. So rational means fraction. So when I say rational exponents, I'm talking about something that looks like that. That's what I mean by rational exponents. Okay, so the reason why we're going to spend some time talking about rational exponents is because doing math with exponents is much easier than doing math with radicals. So what you need to know is that anytime you have something raised to the 1/2 power, that is equivalent to the square root. So 4 to the 1/2 power is equal to the square root of 4, which of course is 2. Great. Okay, so with that in mind, what do you suppose happens when you raise something to the 1/3 power? What is that the equivalent of? That's the equivalent of a cubed root. And the cubed root of 64 is? And the cubed root of 64 is 4. Good, good, great. Okay, so here's the real humdinger. I cannot actually simplify x to the 1/4 power because it's not a number, it's a variable, but I can write this as the 4th root of x. Now, 4th root of x is as simple as it's going to get. Okay, you cannot get any simpler than the 4th root of x. But we need to know how to write it like that because in a minute I'm going to give you some expressions to simplify, and the exponents are so much easier than dealing with the square roots. Let's do a goofy one. 125 x to the 9th to the 1/3. Now having a 1/3 exponent on the outside functions a whole lot like the distributive property, in that this is the same thing as putting the 1/3 exponent on the 125 and the x to the 9th. So what I'm actually doing is the cubed root of 125 times the cubed root of x to the 9th. In other words, the 1/3 power goes to both of those, both the number and the variable. Okay? As usual, the number is the hardest. What's the cubed root of 125? 5. And what's the cubed root of x to the 9th?
3.
X to the 3rd. Exactly right. Exactly right. Now don't get mixed up, don't get tricked by something like this. That one doesn't have parentheses. How is that different? Only the x goes to the 4th root, not the 3. So this one would be 3 times the 4th root of x. So don't get tripped up by that kind of business. Now all of those were pretty basic because every one of those rational exponents I gave you had a numerator of 1, right? What happens if it doesn't have a numerator of 1 though? Then you give up. Yeah, that's it. You're just like, you know what? College is not for me. I quit. My family was right. My minimum wage job down at the farm is the best I can do. Goodbye, college. Do that thing where you multiply. So these problems that we just did, the root that we used was the denominator every time. Square root. This was a cubed root. This was a 4th root. The denominator told us what the root was going to be. So here the denominator is 2. This is going to be a square root. What's it going to be the square root of 4 to the 3rd power? Yes. So this is the same thing as the square root of 4 cubed, like that. And this is relevant to you because if I did 4 to the 3rd power, that's 4 times 4 times 4, and then I would take the square root of it. That's going to be a pretty big number. On the other hand, the square root of 4 is 2. So I can do 2 to the 3rd, which is 8. It would have been okay for me to multiply this out. 4 to the 3rd power is 64. And the square root of 64 is 8. So I would have gotten 8 no matter how I did it, but I don't recommend this way. 4 to the third power is small enough where it's not that big of a deal, but of course you were going to have much more gigantic numbers than that. For example. Negative 16 to the 3/4 power. What's the root going to be?
4.
4th root of negative 16 to the 3rd power. Yeah, because I made a mistake. I'm waiting for you to tell me what the mistake is. Nope.
Oh, no. It can't be a negative if it's even.
Well, you're right. So if this was actually what it looked like, the answer would be not a real number. But I made a mistake here. Going from here to here, I made a mistake. I'm curious if anybody can find it.
The negative goes on the outside?
Yeah, it was related to this one.
Oh.
It's only the thing that has the exponent on it, not the thing out in front. The only thing that had the exponent on it was the 16, not the negative 1 out in front. So this is incorrect. It is negative 4th root of 16 to the 3rd. The negative did not have, if I wanted the negative to be included, I would have had to do it like this. That means the negative goes inside. That's different from this one.
Oh, negative goes outside.
Okay, now you're seeing what I'm saying. 16 to the 3rd power is gigantic. 16 squared is 256. So 16 to the 3rd is 256 times 16. And I ain't doing that. It's much easier to think of this as negative 4th root of 16 to the 3rd power. And here's why. What's the 4th root of 16?
4.
That's the square root of 16. What's the 4th root of 16? 2. So this is negative 2 to the 3rd power, which is negative 8. That is much easier than if I did 16 times 16 times 16 and then tried to find the 4th root of it, which sounds like a nightmare. Hard pass. No thank you. Okay. Let's do one with fractions. Like so. What's the root going to be? Squared. So I'm going to write this as the square root of 1/9 to the 3rd power. What's the square root of 1/9?
1/3.
A third. Square root of 1 over 1/3 of 9.
Why would it be set up like that? Why wouldn't it be? Why wouldn't the 1/9 be in a parenthesis and then like under it the 3rd?
I could have put the 3rd inside the parentheses. It'd be 1 to the 3rd over 9 to the 3rd. That would have been fine. But I just would have big numbers. 9 to the 3rd is a big number. It's 243. If I do it this way, I keep small numbers. Because now I'm just going to cube both of these. It'll be 1 cubed over 3 cubed, which is 1 over 27. I could have done it that way. You're absolutely right. I could have cubed both of these. It just would have been real big because 9 cubed is a giant number. It would have been 243, I think. And then I would have had to square, oh no, it wouldn't have been 243. It would have been even worse than that, wouldn't it? Yeah, 729. Yeah, that's even worse. So and then I have to do the square root of 729, which is 27. I would have got the same answer. Okay. That doesn't seem too bad. Now the way that I remember this is real goofy. The way that I remember which one's the root and which one's the power is I think of a tree. And I remember that the roots of a tree are on the bottom. And the leaves of the tree absorb light from the sun. So this is the power, powered by the sun. That's how I remember power is on top and roots are on bottom. You might think that's a little silly, but you're wrong. It's awesome. How dare you criticize my methods? Whew, man. Okay, so we did fractions to the like 1/2, 1/3, 1/4. Then we did fractions that were improper, like 3/2, 4/3, that kind of thing. What are we leaving out? I just can't think of anything. All right, negatives. We haven't done negative powers. Yeah. I know, I'm excited too. So this is a flashback to last semester, which I'm sure you all vividly remember. Probably wake up screaming in the middle of the night remembering last semester. What do you do with a negative exponent?
Put it on the bottom.
Yeah, you put it on the bottom. So this is the same thing as 1 over 9 to the 3/2 power. 9 to the positive 3/2 power. Okay, so once I have this done, then what?
So with the 1
Square root of
1/9 to the 3rd power?
no, because the 3/2 is only on the 9.
So the 1 would be on the outside.
Right, so it's 1 on the top, and on the bottom, square root of 9 cubed. So square root of 9 cubed. What's the square root of 9? And what's 3 cubed?
9. No.
That's 3 times 3. What's 3 cubed?
27.
Yep, we just did this one. 1 over 27. How about that? That's the same as the last one. Crazy. Okay. Feel right about this so far? Are you praying for a comet to crash into this school and bring you sweet release? Okay, great. Power positive thinking. Good job, class.
I don't get the email.
Huh? You don't get the positive? I'll add you to. I'll forward them to you. Hang in there, just like this kitty hanging off the tree branch. Have you seen the YouTube video of the little panda sneezing and scaring its mommy? So funny. All right, let's go back in time and see if you remember the rules here. How do I put these two things together? I say go back in time. I talked about this just a little while ago. I add the exponents. Okay, so I'm doing b to the 1/3 plus 5/3 power. What is 1/3 plus 5/3? That's 6/3. And 6/3 reduces to, so the answer is b squared. Now, why is this valuable to us? Because this problem was really easy. I just added the exponents, but I could have written this problem like this. Sorry, that's a B, not a 6. These are the same thing. That's the same problem. This problem looks way worse than this one. Here, all I did was add two fractions. On this one, I'm like, my God, how do I even do this? It's the same. This one's b squared. So the reason why we switch them back and forth between exponents and square roots is because doing math with exponents is way easier. Don't you always want to do things the easy way? Now that I've said the easy way, you know I'm going to give you a hard one. But this one isn't even hard because of the algebra. It's hard because the fractions don't have the same denominator. So how do you put them together if they don't have the same denominator? Well, you make them have the same denominator. And you would need to do a third plus a half. What's the common denominator there? 6. How do I write 1/3 in 6? Plus, how do I write 1/2 in 6? 1/2 is really easy. 3/6 is a half. What's 1/3 written in 6th? 2/3. And what's 2/3 plus 2/6 plus 3/6? That's 5/6. So x to the 5/6 power. Do you remember how to do it whenever you've got something like this? You remember what to do when it's division. That's a 9 to the 2/7 over 9 to the 9/7. Do you remember what to do? The bottom's 9 to the 9/7. Top is 9 to the 2/7.
Yeah.
Now I'm just asking how do I put the exponents together. When it was multiplication, I added the exponents. I subtract them. Yeah, subtract the exponents. So 2/7 minus 9/7. Well, that's pretty easy because they have the same denominator. What's 2/7 minus 9/7?
5/7.
Negative.
No,
Negative 7/7, which is -1, right? So this is 9 to the -1st power. Now, I would never write an answer to a problem with a negative exponent. I would switch that so that it has a positive exponent. It'd be 1/9. Good. You are so smart. I don't know what people are talking about. That doesn't seem bad. I feel like we can handle that. I bet we can handle this one too. Oh my God! What happened? Whew! My God, why have you forsaken us? Okay.
This is the point where I slam my laptop down and walk away.
This is, yep. You light your math on fire and walk away in slow motion. Not a bad idea. Okay, but let's break this down piece by piece. First of all, what your dear Aunt Sally says is do what's in the parentheses first. But unfortunately, nothing in this set of parentheses can be combined because we have a whole number and an x and a y, and we can't put any of those together. And the next thing Aunt Sally says to take care of is the exponent, so we're going to do that. Now, the 4 outside needs to go to all 3 of these. Do you remember how to do that? I'm going to leave the denominator alone. This is just going to be 3 to the 4th. What about this one? X to the 1/4 to the 4th. How do I put those together?
5/4.
You're adding. I actually multiply them. 1/4 times 4 is 4/4. So it's just 1. And then y to the, what's negative 2/3 times 4? That's negative 8/3. Normally I'd be done, except I've still got some x's on the top and bottom, and I got some y's on the top and bottom that I need to put together. What's the deal with the x's? I got one x on the top and 4 of them on the bottom. That's 3 on the bottom, exactly right. So I'm going to have 3 to the 4th. I'm just going to write that as 3 to the 4th for now. And then I have x to the 3rd on the bottom. I had 1 on the top and 4 on the bottom, so the 1 on the top cancels with 1 of the 4 on the bottom, leaving me with 3 on the bottom. Okay, what about y's? That's a little trickier. How do we combine them when it's division? We subtract the exponents, so it's going to be negative 8/3 minus y to the 1st, so 1. Negative 8/3 minus 1. Writing 1 as a fraction is pretty easy. That's 3/3, right? And negative 8/3 minus 3/3 is negative 11/3. So on the top, I would have y to the negative 11/3. But it's not okay to write your answer with a negative, so how do I fix that problem? The 3 to the 4th is fine. I'm just going to go ahead and multiply that. It's 81. The x to the 3rd on the bottom is fine because it's a positive exponent. But the y to the negative 11/3 is not fine because it's a negative exponent. So I'm going to drop it down on the bottom. And that monstrosity is the answer. Okay. Let's talk about how to multiply them. It's everybody's favorite property, the distributive property.
Is that 1/3?
Are you criticizing my handwriting?
No, it's blurry.
Oh, so you're criticizing your eyesight.
Yes.
Fair enough. That is z to the 2/3 on the outside, and on the inside, z to the 1/3 minus z to the 5th. Cool. So the distributive property says the thing that's outside gets multiplied by both things on the inside. So let's do that. This is going to be z to the 2/3 times z to the 1/3. That was the first group. Minus z to the 2/3 times z to the 5th. How do we combine those things together?
Wait, why is it minus z to the 2?
Because minus sign right here.
I thought it was a 5.
You thought what?
Wouldn't it be z to the 5th that had a negative in front of it?
It's multiplication, so it is. I did 2/3 times 1/3 and then 2/3 times 5. So here's 2/3 times 1/3 and here's 2/3 times 5. Okay, so this one's easy because they already have the same denominator. So I can just add them. What's 2/3 plus 1/3? 3/3, which is 1, right? Z to the 1st power. That one's not too bad. Minus, this part's trickier because I got to do 2/3 plus 5. So 2/3 plus 5. I need to rewrite 5 so that it's in thirds. So 2/3 plus how many thirds? How many thirds is 5?
3 times 5,
Uh-huh.
so it's
15. Good. What's 2/3 plus 15 thirds? 17 thirds. So this is z to the 17 thirds. Whew! My sweet Lord. That's the answer. Z minus z to the 17 thirds. I can't simplify any more than that because they have different exponents, so I can't combine them. You only combine them with the same exponents. Okay. That's the end of the problem. So, let's put together what you know. Can you simplify that? So recall our tree. Power on the top, root on the bottom. So that's the 8th root of x to the 4th power. So if I were going to rewrite this as a fraction or a rational exponent, it would be x to the 4/8. Root on the bottom. That's the 8th root of x to the 4th, so root on the bottom, x to the 4/8. X to the 4/8 reduces to, that's 1/2. And anything to the 1/2 is, so the 8th root of x to the 4th is the equivalent of the square root of x. Okay. Now this is really cool. So I could type the 6th root of 5 or 6th root of 25 into the calculator and get a decimal answer, which is all right. But if I type it into the calculator and I get a decimal, I'm going to have to round that answer. And I don't want to round that answer. I want the exact answer, not a rounded answer. So here's something I can do. This 25 is like 25 to the 1st power, right? So let's write this as 25 to the 1/6 power. Now something that I notice about the number 25 is that 25 is a perfect square. What is the square root of 25?
5.
So I could write this as 5 squared to the 1/6 power. Do you recall how to simplify this?
No.
Huh?
No.
Okay, cool, cool, good talk. How do you put these two exponents together?
We add.
You multiply. 2 times 1/6 is 2/6, which reduces to 1/3, which is the same thing as the cubed root of 5.
See, I don't get how you just got that. Yeah, I don't either.
Where did I lose you?
Where it goes from the exponent, like the little parentheses, to the next
This one?
one.
Anytime you have a base raised to a power raised to another power, you multiply the powers.
Oh,
2
okay.
times the 6th was 2/6.
Okay.
And then I reduce 2/6 to a third, and anything to the 1/3 power is the same thing as the cubed root. Okay, so here's one of the ways that we can use this. We can use it to simplify something like this. This problem would otherwise be impossible to solve. But good news, we can answer it now. Because I can't put these together, they have different indexes, they're different roots. So one thing that I can do is to rewrite them as fractions. So this would be x to the 1/3 times x to the 1/4. Okay? And that I can put together, because I can do 1/3 plus 1/4. I can add those exponents. What's the common denominator of 1/3 and 1/4? 12. So how many twelfths do I turn 1/3 into? 4 twelfths. And how many twelfths would 1/4 be?
3,
For a total of
7.
7 twelfths. So I can write this as x to the 7 twelfths power. Now my original problem was given to me as a root, so I want to go ahead and convert it back to a root. How do I turn x to the 7 twelfths back into a root? So what's the root going to be? 12th root of x to the 7th. And that is a way that I can take two separate square roots and combine them together into one root. And when you think about it, if you've gone your whole day without combining two roots into one root, have you really lived at all? I would argue no. I would argue your day is not complete until you've turned two roots into one root. Does anybody have any questions about this other than sweet Jesus, is it over yet? No?